Okay, now we're in Google Maps and we're going to use the terrain function within Google Maps to take a little bit closer look at some of the finer points of the relative evolution of anticlines and synclines within the Appalachian landscape, where we have this mid-level, very resistant sandstone with weaker rock, older, weaker rock, deeper in the section underneath it. So, got Beartown Mountain, Lebanon, Virginia, just like in Google Earth. Google Maps will take us there, and at this point, turn on the terrain function here. Really remarkable functionality of this program. Really cool way to take a look at the Earth's surface, particularly in topographically exciting places like this. And here is the remnants of that little syncline that now develop that localized plateau with the very high Beartown Mountain peak on its southwestern end. If we zoom out a little bit, you can see that there's a lot of topographic variety here. There's Morris Knob from the first video, very high point within the landscape. There's Balsam Beartown Mountain, another localized syncline, very high within the landscape. And if we go back to our first Beartown Mountain and move just to the east, we can actually see the process by which anticlines that might initially and briefly support high topography are breached open, or sort of cracked open if you will, and ultimately end up turning into valleys like the valley that you see here. And to look at that, we'll zoom in a little bit closer here. So what you're looking at here is an anticline that is capped by that resistant sandstone. The cap is still in place right here, but where you see this sort of big gouge out of the mountain, that's where this capping rock has been eroded through, and it's exposing calcareous shale, so carbonate bearing shale underneath it. It may be carving down even further to get into some of the deeper limestones and dolomites within the section, but all that to say, after this cap rock is gone, all bets are off. And when these steep streams that are very steep as they flow down that cap rock, the cap rock is very hard, and also just its dip here is going to have considerable impact on the gradient of these streams. As those steep streams and this steep landscape is suddenly brought into contact with this much weaker rock underneath it, erosion is going to run wild, and you can actually see this huge fan of material that's being scoured out of this small stream basin here and dumped out in the valley floor. And it's coming out of this basin here so quickly that it's piling up in the valley floor, and these lower gradient streams can't even get rid of it in time. And what you're seeing here is, again, what we call breaching of an anticline. So you can see that intact cap rock, and I'm going to put a little diagram up here in the top right corner of the screen to try to give you a conceptual idea of what's going here to help visualize it. But the whole idea is that when you take a steeply sloped landscape and high gradient streams draining that steeply sloped landscape and allow them to cut through that cap rock and encounter this soft material, those steep streams are way too steep. They're much steeper than they need to be to erode that soft material, and you're going to get a very rapid jump in erosional efficiency and start carving a big hole out of this anticline. And you can see that this basin here is sort of growing and spreading. Here the cap rock has been breached. These are spreading as well. And that's actually what this entire valley system that you see here is. This big anticline here has been breached over a large area, and all of that weak material deeper in the section has been exposed, and you can imagine this stream here sort of taking a bite, if you will, out of what was a topographically dominating anticlinal structure, sort of like you see here. So again, this only works in places where you have mechanical variability within the section that is deformed. In this case, the capping layer is Silurian age. The Ordovician and Cambrian rock beneath that is dominated by carbonate. It's much weaker in this landscape, and once you cut through that armoring layer, get into that soft stuff, those streams are really going to like that. That's a great way to be erosionally efficient, particularly when you're starting off with a high gradient, and erosion is just going to run wild. Now, in synclines adjacent to these growing anticline-associated valleys, the soft rock is not available at the surface there, and as these valleys grow bigger and bigger and sort of eat into the margins of the syncline, the streams that drain through and out of that syncline are constantly losing drainage area. So not only is there a lot of hard rock exposed in the axis of this syncline, that hard rock is nearly flat lying, and as these valleys grow and the syncline sort of plateau valley gets smaller, it's losing drainage area as this is constantly gaining drainage area and stream power. So erosion is really just going to sort of grind to a halt in these little plateaus, and they'll ultimately have to be consumed just by collapse of the edges of this cap rock unit. So by constantly starving them of water and stream power, while next door larger streams that are in softer rock sort of erosionally go crazy, these little synclines end up as just little postage stamps within the landscape that don't really have a way to efficiently play catch up erosionally with what's going on where softer rock is exposed around them. And that's why they tend to be very persistent features within the landscape. If we cruise up here and take a look at Morris Knob, which approaches, here at its summit, it actually approaches the elevation of the Beartown Mountains. There's very little cap rock still present here, but it is present. There's no stream power going to work here to remove that material, and it has to be consumed again just by collapse of the edges of this plateau. The rock's not steeply dipping. It's going to be sort of more difficult, if you will, for gravitational processes to go to work on that than if it were vertically dipping or very steeply inclined towards the valley. So this little syncline plateau caprock style feature is just going to sit there within the landscape while the anticlinal valleys next to it continue to develop and deepen. Ultimately, this material will collapse away and its armoring effect will be lost, and this entire valley will become flat, sort of like you see here. Certainly this syncline would have been present along strike. It would have been structurally a bit higher through this area. It's already been eroded away, and here you just see that uniform carbonate valley geometry. But to see the process in action, you really can't do much better than this area where you see that sort of hump-shaped, almost kind of whaleback geometry where the anticline's still intact, where the steep streams have broken through that hard rock and gotten at the shale, the calcareous shale underneath it. Erosion has gone nuts. Huge fans of material are sloughing out of these basins. These basins are expanding and growing bigger, and like you see here, gradually consuming this large fold structure and turning it into a broad valley. This is going on in a large area here because this entire part of this structural mass of this thrust sheet is host to this big anticline. It's very extensive along strike. It's being breached through here. That's happening again down here to the southwest. And this one's really cool. I like this one because the fan development here is just really, really extreme. So here you can see a stream valley that has cut through that cap rock. It's exposed to softer material underneath, and so much debris is being blown out of this valley that it has sort of buried underneath this area. It's buried this knobby, hilly topography that you'd normally associate with bedrock outcrop in this area. So if you were to drive up the road I'm following here, you would go up a very steep hill in this location. You're not driving up a bedrock hill, you're actually driving many tens of meters up the edge of an enormous alluvial fan that's being blown out of that valley and is just choking and drowning the more axial valley here at the foot of the mountain. So what do you find on top of the hill here? Another synclinal plateau, and you can get the impression that as these little drainages here eat their way deeper into the plateau, it's going to continue losing drainage area, and ultimately you're going to find sort of a Beartown-like postage stamp plateau top in this area here that will be a very high point in the landscape once all the surrounding areas have been lowered down to sort of match the rest of the soft rock valleys in this region.